Hello, hi everyone. Welcome to the student brand. So this is what's sir. So today topic is light reflection and diffraction. Light is a form of energy which gives the sensation of sight. Okay. Here today class completely we will discuss about reflection of light, regular reflection, irregular reflection. After that, so nature of the image formed by the plane mirror, real image, virtual image. And after that we will discuss spherical mirrors, concave mirror and convex mirror. After that, terms related to spherical mirror. And the next one are ray rules, image formations. So after that, we will discuss about lens. Okay, so let us start. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. So I am taking here a plane mirror. So this is a plane mirror. I'm considering this is a plane mirror. This is a plane mirror. Okay. So this is the incident ray, reflected ray, incident ray, reflected ray, and the line which is perpendicular to the plane surface is called normal line. The light ray which is perpendicular to the plane surface is called normal line. So few questions also we'll discuss, not only theory. So we'll discuss question and answers also. Okay, so be ready for it. So incident ray, reflected ray, incident ray, incident ray. So this one is the reflected ray, reflected ray, and this one is considered as a normal line, normal. And the angle between incident ray and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. And the angle between reflected and deviated line is called angle of deviation. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called a reflection of light. Okay. So here you can see incident ray, reflected and normal line. So the light ray is can observe here. So incident ray, reflected and normal line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. Angle between reflected and deviated line is called angle of deviation. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called a reflection of light. Okay, so here first point, coming to laws of reflection. Laws of reflection we'll discuss. Laws of reflection. Laws of reflection. Okay, coming to laws of reflection, point number 1. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. And point number 2 is, so angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So linear angle you are taking, linear angle is 180 degrees. Linear angle is 180 degrees. So in that I can take here angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So according to the definition, angle of incident is equal to angle of reflection. So by that, angle of incident is equal to angle of reflection, right? So we can substitute here angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence, and we can also take angle of deviation equal to 180 minus 2 angle of reflection. So in the place of angle of incidence, angle of reflection, if you substitute angle of incidence, you will get this. In the place of angle of incidence, if you substitute angle of reflection, you will get this value. Okay, so that is angle of deviation formula. Angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. So I hope it is very clear, right? Next, so we'll discuss regular reflection and irregular reflection. Regular reflection and irregular reflection. Regular reflection takes place on smooth surface, whereas irregular reflection takes place on rough surface. Regular reflection takes place on smooth surface. So incident rate is these are the incident beam, incident parallel beam. So even reflector light rays are also parallel to each other. So reflector light rays are also parallel to each other. Reflected parallel. Okay, incident parallel beam and reflected parallel beam. Okay, so I hope it is very clear. This is called regular reflection. Regular reflection. Coming to irregular reflection. So here reflector light rays are not parallel to each other, so they'll move in different direction. Reflector light rays are not parallel to each other. reflector light rays are not parallel to each other. Incident light rays are parallel, but reflector light rays are not parallel to each other. So they'll move in different directions. Incident beam, reflected beam. So this type of reflection is called regular reflection. This type of reflection is called irregular reflection. Okay. So regular reflection and irregular reflection. Now we will discuss about nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror will discuss. So here you can observe this is a real object, this is a virtual image. Real image and virtual object. Okay. So object and image. Object is real, image is virtual. Object is virtual, image is real. So you have to understand one thing. So you have to observe carefully. So here you can see. So from this point, incident light rays are coming. From this point, incident light rays are coming. The point of intersection of incident light rays is called real object. So we are extending the reflector light rays. Extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. So that image is called virtual image. So here you can observe directly reflector light rays are meeting at one point. Directly reflector light rays are meeting at one point. So their image is forming. That's a real image. We are extending the incident light rays. Extended incident light rays are meeting at one point. There extended incident light rays. These are the incident light rays. We are extending those incident light rays. Extended incident light rays are at one point. So they are virtual object. Virtual object. So this is about real object, virtual image, virtual object, real image. Okay. Next one. Next one, we will discuss about nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. So be ready. Here you can see this is a plane mirror. Okay. Nature of the image formed by the plane mirror, right? So I'm taking the object is here. This is the object. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Yes or no? So I'm considering one light ray. So this is one light ray I'm taking here. After reflection, the light rays are moving away from it. So here you can observe. So here you can observe. First point, object is real, image is virtual. Object is virtual, image is real. Second point is, this is the distance between object to, this is the distance between object to object. This is object to mirror. Object distance, the distance between mirror to image is called image distance. The distance between object to mirror is called object distance. The distance between mirror to image. So middle one is the mirror. So this one is a mirror. Okay, now mirror to image is called image distance. Mirror to object is called object distance. Okay. So now second point is, we can take object distance is equal to image distance, and the height of the object is equal to height of the image. And the next one, fourth one, it also shows lateral inversion. So what is the lateral inversion? What is the meaning of lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Okay, once again, so here I can observe. So object is real, image is virtual, image is real, object is virtual. Object distance is equal to image distance. Height of the object is equal to height of the image. And also it shows lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. So next one we will discuss about spherical mirrors. So spherical mirrors, the mirror which in the form of curved shape, the mirror which in the form of curved shape is called spherical mirrors. Okay, if you are taking the small portion, we are taking the small portion of it. So I'm taking here, and if you are taking the small portion, that is called spherical mirror. Like this, I'm taking the mirror which in the shape of curved shape, that is called spherical mirror. There are two types of mirrors: concave mirror and convex mirror. Concave mirror and convex mirror. One is concave, so I'm taking here. This is a concave mirror, and the next one is convex mirror. Concave, and the second one is convex mirror. This is a concave mirror, this is a convex mirror. Concave mirror, and this one is the convex mirror. Convex mirror. Okay, concave mirror and convex mirror. So concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror, because whenever light rays falls on it, the light rays will be converge and meet at one point. That's why it is called concave mirror. It is also known as converging mirror. So here you can observe. So after reflection, those light rays are moving away from it. So concave mirror. After reflection, light rays are moving towards the principal axis. That's why it is called converging mirror. So concave mirror is also known as converging mirror. Converging mirror. And a convex mirror is also known as diverging mirror. Diverging mirror, because light rays are moving away from the principal axis. Here light rays are moving towards the principal axis. That's why concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. Right? Okay, done. Now, so we'll discuss about terms related to spherical mirror. We can observe here. Terms related to spherical mirror. So we are taking the small curvature here. Okay. That's why I'm taking the small curvature. So this is the pole. So this is the midpoint of the mirror, the center of the imaginary sphere. The center of the imaginary sphere in which mirror is a part. This is called center of curvature. Midpoint of the mirror, and after reflection, all light rays will meet at one point on the principal axis. This is called focus. Okay. So the distance between center of curvature to pole is called radius of curvature. The distance between center curvature to pole is called radius of curvature. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. And width of the mirror is called aperture. First one is center of curvature. First one is center of curvature. Center of curvature. Focus. Pole. Radius of curvature. Radius of focal length. Aperture. Width of the mirror where reflecting taking place. And Santon, the line joining of center curvature and pole is called principal axis. Line joining of center curvature and pole is called principal axis. Principal axis. Okay, so these are the terms related to spherical mirror. Terms related to spherical mirror. Once again, so this is a part. So after reflection, all light rays will meet at one point on the principal axis called focus. The midpoint of the mirror is called pole. And the distance between center curvature and pole is called radius of curvature. The distance between focus to pole is called focal length. And width of the mirror is called aperture, reflecting surface. And coming to the line joining of center curvature and pole is called principal axis. Okay. So I hope it is very clear. So now, so we'll discuss. So do like, share, and subscribe to Student the Brand. If you like the content, if you like the channel. Thank you.